Right. Hello, everyone. Welcome back, my chemistry kings and queens. It is 6 o'clock on a Thursday, and we are back for another super exciting chemistry squad. It's super, super great to be back here, guys. And I'm sure we're going to see many of you rolling in really, really slowly. No rush at all. We'll just take a good 5 minutes or so for everyone to get comfortable. Get a glass of water. The weather is absolutely baking. So I hope you're all staying hydrated, getting that good old H2O. And funnily enough that I mentioned H2O because that's a covalent molecule. And that's what we're going to be talking about today. We're going to be talking about ionic, covalent, and metallic bonding. But by all means, as you're all rolling in, feel free to say hi. Don't be a stranger at all. The more engagement, the better. And as always, we'll be teaching for a good half an hour at the very beginning, and then we're going to be doing some Q&A for the last 15 minutes. So by all means, do stick around. T, I do remember you. Hi, I'm just going to read out your message. Hello, I'm not sure if I remember you. I do remember you. Not a problem. But I did study tips. You're now 2 exams away from finishing your GCSEs. Thank you for all the study tips you gave me. It's not a problem at all. Firstly, welcome. It's great to see you here. And secondly, I'm glad that the tips helps. The one thing that I've always said is the reason that we put together these squads is so that we can make you the best students that you can possibly be. And I know all of you have worked really, really hard to get to where you are now, and you should be super proud of yourself, T, for being 2 exams away from finishing your GCSEs. That is a monumental achievement. So well done. You've absolutely smashed it. Well done, buddy. Genuinely proud of you. And you should be proud of yourself. That's the main thing. Like I mentioned in my study squads tips, 2 terms ago now, we don't do a good job generally as people of giving ourselves a pat on the back. So please make sure that you do that. Either go out with friends, celebrate with your family, do something for you to say well done for finishing your GCSEs, because that's absolutely amazing. Well done, well done. But great to see you here all the same. Honestly, it's great. I think that's the type of positivity that we like to sort of start with. So that's great. It really sets a good vibe for the rest of the evening, really. Okay, we're going to give it 2 more minutes or so, and then we're just going to lay out some ground rules, and then we'll get straight into chemistry. But if you haven't already, like I said before, just get comfortable. I see a few more of you rolling in. Don't be afraid to say hi. But yeah, just get some tea, get some water, and yeah, half an hour of teaching, and then 15 minutes towards the end. Of just some Q&A, so feel free to stick around for the whole thing. I definitely encourage you to do so. And also make sure that if you like these squads and you want My Tutor to keep doing them, make sure you smash that like button. You can also subscribe to the My Tutor YouTube channel so that if we upload anything else, then you'll be the first to know about it as well. So that's also important. And if there's anyone else that you think might find these sessions useful, then by all means, do share the link with them. And T, I just wanted to come on here and say that because I saw you on YouTube. Physics and DT left. Thanks again. God bless you. God bless you as well, T. Honestly, like I said before, you should be super, super proud of yourself because finishing your first round of GCSEs is a monumental achievement, and I'm sure you've worked really, really hard, and you should be very proud of yourself. It's nothing to thank me for. Thank you for coming to every squad session, and thank you for working as hard as you did. So I don't actually have my gold trophies in the room like I normally do, but if I did, then I'd happily hold one up for you, buddy. But do enjoy the rest of your evening, and good luck for physics and DT. I'm sure you'll smash them all the same. But great for you to sort of pop in and say thank you. It is appreciated. I'm glad you found the sessions useful. Okay, so I can see a few more of you rolling in. It's 5 past, so I think we'll just get started with the actual content. Like I always say, just a few ground things. Number 1, there is no such thing as a silly question. If you do have a question, pop it in the chat because you never know, someone else might have the same question. And that's how we all learn as a collective. Secondly, there are other squads you can check out, so do make sure to check out the My Tutor YouTube channel, and you'll also be able to see when they are going live. I always go live on a Thursday at 6 o'clock until 6:45, and there is a link in the description of this video where you can pop your details in, and you'll get a reminder every single time myself or one of the other tutors is going to go live, so do make sure to check those out as well. Like I said before, if you do like this kind of content, make sure you smash the like button so that we know that you like this kind of stuff and you can keep viewing. Additionally, you will get a feedback link towards the end of the session. Inga, the lovely moderator, will post it, and she'll post it towards the end of the session. Really, really important that you fill in that feedback form, because the more feedback we get, the more we know how to tailor these sessions to what you guys want and what you guys need. Like I've said before, the aim is to make sure that you guys are the best students that you can possibly be. So yeah, by all means, just give us as much feedback as possible. With that being said, I think we should just get right into it. Let's start talking a little bit about structure and bonding. Okay, now, structure and bonding, I think, is one of those topics that always comes up in exams. And obviously, a lot of you who are watching now, you may have finished your exams if you're in year 11, or you might be thinking about your exams if you're in year 10, or you may have just started chemistry if you're in year 9. So either way, for those of you in year 11, this might not be as useful, but for those of you in year 9 or year 10 who are watching, definitely useful. So let's talk a little bit about structure and bonding. Now, this is a topic that I think comes up a good amount, and you'll always get like 6 markers on it. You'll always get maybe some 4 markers. You never really know how you're going to be assessed on these types of questions. So what I really want to focus on today is kind of go over the main points, okay? Just so by the end of it, you have a decent understanding of some of the key concepts that come around with structure and bonding. So the first thing to sort of think a little bit about is why things react in the first place. So last lesson, we spent a bit of time looking at the periodic table and looking at the history of the atom. And one of the things that we talked a little bit about was the fact that the atom is made up of protons and neutrons in the nucleus, and then electrons which then orbit the nucleus. What we also understand is that we have differing amounts of electrons depending on the atom. Now, if you look at your periodic table, okay, all the different elements are arranged in groups. So you've got things like sodium and lithium in group 1, you'll have magnesium and calcium in group 2, and on the far right-hand side of the periodic table, you'll have things like chlorine and fluorine in group 7, and things like oxygen in group 6. Now, the great thing is that the group number actually tells us how many valence electrons there are. Now, valence electrons is just a fancy way of saying how many electrons are in the outermost shell. So, for anything in group 1, there's always 1 electron in the outermost shell. For anything in group 2, there's 2 electrons in the outermost shell. And then for group 7 and 6 respectively, anything in group 7 has 7 electrons in the outermost shell. Anything in group 6 has 6 electrons in the outermost shell. Hi Finn, no need to apologise whatsoever, you're all good, bud. Great to see you here again. Thanks for joining again. I know you were here last week. You've not missed anything, just a few hellos, a few intros, and we're just getting into the actual content now, just getting started on structure and bonding. So, if we think a little bit about how these different elements have different amounts of electrons in their outermost shells, what we can do is we can think a little bit about a special group in the periodic table. That's group 8. Now, group 8 consists of elements known as the noble gases, and I'm going to type that out. We're going to say that group 8 consists of the noble gases. And the really interesting thing about the noble gases is the noble gases are what we would describe as inert. Okay? Now that's a really, really interesting word. I see a few more of you have joined. Good to see you. What do we think the word inert means in chemistry? Right? Don't worry about putting your hand up. Obviously, it's a live space. So what do we think the word inert means? We'll just get 2 answers and then we'll just keep the momentum going. So what does the word inert mean to you from a chemistry perspective? All right, Finn, you said unreactive, smashed it. I'd agree with that. Anything else at all? I did not know I could use the heart react thing. That's what that is. That's actually really cool. But yes, unreactive. I'd agree with that. I see a lot of heart reacts. I'm assuming a lot of people are backing that answer. I agree. Okay, inert means unreactive. So things like helium, things like neon, things like argon, they're all unreactive. And the reason that they're all unreactive is because the noble gases, okay, and we're going to add to this, the noble gases are inert because they have a full outer shell of electrons. So in reality, they have no need to react with anything, okay, because they have a full outer shell. And so then this leads us on to this point of why is it that all these other elements in the periodic table do react? Well, they react because they are not chemically inert, because they don't have a full outer shell. So what that then helps to understand is that things in the periodic table generally react to become more stable. And by becoming more stable, I should say, by gaining a full outer shell, they become more stable. What we can say there. Lyrics, good to see you. Hope you're well this lovely evening. Thanks for joining for another live stream. So, if we think a little bit about bonding then, let's talk a little bit about bonding. So, we'll start off by thinking about ionic bonding. Ionic bonding comes about by virtue of a metal reacting with a non-metal. So ionic bonding happens when a metal reacts with a non-metal. Now, let's take sodium and chlorine, for instance, okay? And I'm going to do a little bit of drawing here, okay? Now, sodium is in group 1 of the periodic table. So, in terms of doing a dot-cross diagram, where my crosses are my way of representing electrons, I'm going to do a cross. And I'm only going to do one cross because I know that sodium's only got one electron in the outermost shell, because it's in group 1 of the periodic table. Chlorine, on the other hand, is in group 7. So I'm going to do 7 dots around chlorine, like so. Okay? So that's what I've got going on there. Alright? I'm well, Lyrics. I'm good. How are you? Hope you're well. Thanks for joining. So, we've got 1 electron in the outermost shell for sodium. We've got 1 electron, there's 7 electrons in the outermost shell for chlorine. So when these two react, what's going to end up happening is they're going to give and take electrons. Okay? Sodium's going to give that electron to the chlorine. So sodium's going to lose electrons and chlorine's going to gain an electron. So then sodium becomes a positively charged ion, right? And we call it a cation. Okay, so it becomes a sodium cation. And chlorine is going to gain that electron from the sodium. And now you have Cl minus. And this is a chlorine anion. So that's what we have going on there. Okay, so then when we think a little bit about ionic bonding, we can describe ionic bonding as an electrostatic force of attraction that exists between these oppositely charged ions. Now, the reason that I've used those words in particular is because they're words that loads of examiners like to see. Okay, so whenever you guys have been doing past paper questions, I'll say you've been marking any of them, you may have realized that actually electrostatic forces of attraction is a way that we would describe an ionic bond. Okay, and they exist between these oppositely charged ions. Now, the great thing is, when it comes to figuring out what reacts with what and how many electrons are given and how many electrons are taken, we can refer back to the group numbers that all these elements are in. So we know that metals will always lose electrons, right? So if a metal's in group 1, it's going to lose 1 electron, because by losing 1 electron, it then has a full outer shell. If a metal's in group 2, it's going to lose 2 electrons, because by losing 2 electrons, it will gain a full outer shell. Similarly, with group 7 and group 6, we know that the non-metals will gain electrons, if an element in group 7 is going to gain an electron, it's going to gain the 1 because then it has a full outer shell. And similarly, if anything's in group 6, it's going to gain 2 electrons. And then it gains a negative charge of 2 minus, but then it also has a full outer shell. Okay? Now, the next thing to think about is the properties. And that's something they always sort of ask about in exams. They're always asking, well, what about the properties of all these different things, right? So actually, I'm going to erase this part just to make a bit more space. When it comes to ionic compounds then, which again we've talked a little bit about, right? We've said that they're made of ions, and the ions are oppositely charged. You have this electrostatic force of attraction between the ions. Okay? What we can then say is that ionic compounds have certain properties. And in an exam, it's not uncommon for you to be asked about those properties. Okay? So, one of them is that, and I'm going to use a different font just to jazz it up a little bit. One of the things with ionic compounds is that ionic compounds have high melting and boiling points. And the reason they have high melting boiling points is because the strong electrostatic forces of attraction between the ions requires a lot of energy to overcome. Okay? When we think about melting points and boiling points, and actually, you know what, I'm just going to adjust the font just so we can see it all on the same page, because at the moment it's running off the page. There we go. Okay. So when we think a little bit about melting points or boiling points, they're just a requirement. It's a certain amount of energy that's required to either melt something or boil something. So if we think about it from that perspective, then the higher the melting point, the more energy required to melt something. Okay, so that's what we can say about ionic compounds. They have high melting points, they have high boiling points. Now, I'm going to give a property, and I want you guys to tell me why it has that property. So, ionic compounds cannot conduct electricity when they are solid, but they can conduct electricity when molten or in solution. What do we think? What's the reason for that? Why can ionic compounds not conduct electricity when solid, but they can when molten or in solution? Really interesting one. It's a bit of a tricky one. The question comes up every so often, and I think it's worth knowing about. I'll give you guys 2 minutes. Okay, let's see. So, Finn, you said because of the free-flowing electrons. Okay, we're on the right lines. Yeah, we're on the right lines. So it's something to do with charged particles not being able to move around. Yes. I see a lot of heart reacts on that comment, so we're going to keep with the momentum, but that's correct. So, in ionic bonding, okay, and this is actually something that I think we have to be really careful of whenever it comes to answering questions. The ability to conduct electricity conventionally is to do with electrons, but when we think about ionic compounds, the ions themselves are charged, aren't they? So, because of that, the ability to conduct electricity isn't so much to do with electrons, specifically when we're talking about ionic bonding, but it's more to do with the ions themselves being able to move. Okay? Now, when the ions are held together in place, when they're in a solid form, okay, the ions are all locked into place in this lattice, okay? So they can't really move around very well. It's very difficult for them to move around. So they can't conduct electricity for that reason. But when you melt an ionic compound, when you put it in solution, the ions are free to move around and therefore carry a current. Now, Finn, you've actually brought up a really good point. You've talked about ions being able to slide over each other. And that's more to do with metallic bonding. So in metallic bonding, the ions are arranged in layers and you have delocalized electrons. And in that situation, the electrons are able to move around quite freely because they're delocalized. So that's more to do with why metals on their own can conduct electricity when solid. But remember that ionic compounds, so let's say sodium chloride or magnesium chloride or potassium bromide, these are all examples of ionic compounds which can't conduct electricity when solid because the ions are all locked into place. But when they are free to move around, i.e. when they're molten or in solution, then in that situation, they can carry a current because the ions are free to move around. So slight difference there between metallic bonding and ionic bonding, but generally we're on the right page. We're going in the right direction. Now, does that make sense for everyone? Give me a quick thumbs up if it does make sense. If it doesn't make sense, let me know. And then we'll go over it in the Q&A session towards the end of today's squad. But while we're having a think as to whether it makes sense or not, then what I'll do is I will just, I'm going to type what I've said up. So I'm going to say ionic compounds can conduct electricity only when molten or in solution. This is because when in the solid state, the ions are held together by the electrostatic forces of attraction. When molten, the ions are free to move around and carry a current. Smashed it. Okay, that's what we can say there. Now, I've not done too well in terms of space, so I'm just going to pop this. I'll pop it. I didn't think this through. That will have to do for now. That will have to do. Okay, so that's what we can say about ionic bonding. What I'm going to do, because I'm semi-conscious of time, is I'm going to quickly go over metallic bonding, and then I'm going to finish off with looking at covalent bonding, because that's the one that I think takes up a lot more time. So we've just talked a little bit about metallic bonding, haven't we? We've said that it really consists of the metal ions in a metal being arranged in layers, okay? And we have delocalized electrons that are then able to move throughout the structure. Now, what I'm going to do to get you guys more involved is I'm going to ask you about some definitions that we specifically use in metallic bonding. If I asked you all, what does the word ductile mean? What would you say? And similarly, if I asked you all what the word malleable means, what would you say? I'm going to do a drawing of what metallic bonding looks like. And while I'm doing that, I want you all to tell me what malleable and ductile mean. So, that's too thick of a pen. Let's just do a quick bit of drawing. So, what does malleable mean? And what does ductile mean? I'm just going to draw this diagram out, and then we'll have a little bit of a discussion about it. Like I always say, I can't claim to be a good artist at all. I didn't take art GCSE for a reason. There we go. So these are all my positively charged ions. And then I'm going to draw the electrons in, we'll say blue. We'll say blue. Okay, so Finn, you said that for ductile, they can slide over each other, and then you also can change shape. Okay. Oh, okay. So your first one was malleable. Sorry, they can slide over each other and they can change shape. And then you said to be made into a wire means ductile. Smashed it. Let's give a heart react for Finn's answer because Finn's absolutely smashing it today. Well done. So, That's exactly what malleable and ductile mean. Okay, so when a metal is malleable, it means that we can bend it into shape, and the reason that it can do that is because the ions can slide over each other very, very easily. And actually, we can use the same type of thought process when we then think a bit about um, malleability, ductility, because to pull something out into a thin piece of wire, the ions need to be able to slide over each other, which they can. Okay, so even though they've got these electrostatic force of attraction between the ions and between the electrons, um, ultimately they can slide over each other really, really easily. So that's fine. Okay. Metals are obviously able to conduct electricity. This is because your electrons are free moving, they're delocalized, so they can move throughout the structure super, super easily. Okay. And they are also really good thermal conductors, again, because the electrons are able to carry current throughout the structure and therefore carry thermal energy throughout the structure as well. All right, fantastic. And so finally, we will finish off by looking at covalent bonding and covalent bonding. That's what we'll look at. Hi, Mohammed. Good to see you this evening. Hope you're well. Hope you're well, buddy. Thanks for joining. So, if we think a little bit about covalent bonding, then you have two different types of covalent bonding. You have simple covalent bonding and you have giant covalent bonding. Now, your simple covalent molecules generally consist of things like H2O, things like CO2, and they don't consist of many atoms, and they're all held together by covalent bonds. Okay, and a covalent bond is what exists between two nonmetals. Okay, where the electrons are shared between the two atoms, so that a pair of electrons can then be sort of shared between two atoms when they need a full outer shell. Now, the key points to note with your covalent bonding is that ultimately you don't have what's the word I was going to mention here? Let me have a think. Sorry. You don't have many atoms, and because you don't have many atoms, ultimately what you have is you don't have many strong, not covalent, intermolecular forces between the molecules. Okay, so ultimately, you don't have very strong intermolecular forces, which means that it doesn't require a lot of energy to overcome those forces. So their boiling points and melting points are generally quite low. Additionally, your simple covalent molecules don't have any free moving electrons, so they can't conduct electricity. Your giant covalent molecules, I think in an exam, this is generally where you tend to be asked more questions, refer to things like graphite and diamond. So your giant covalent molecules consist of multiple atoms, and as a consequence, you have much stronger properties. So, for instance, diamond and graphite both have really high melting points because you've got loads and loads of atoms, you've got loads of strong covalent bonds that need to be overcome, and there's strong intermolecular forces. Diamond is unable to conduct electricity because it's got no free electrons, but graphite is able to because each carbon atom in graphite is only bonded to 3 carbon atoms instead of 4. So there's 1 free electron per carbon atom. Okay? And finally, graphite is quite soft, and that's because your layers can slide over each other. And again, a diamond is quite hard. So as a consequence, diamond is hard because layers aren't able to slide over each other, I should say. Sorry, I think the heat is getting to me a little bit. But I hope that makes sense for everyone. Does anyone have any questions about structure and bonding at all? We're going to move into the Q&A session now, the Q&A part of the session, but I hope you found that useful. So, Mohammed, I know you've asked a question here. Have I done a lesson on moles and excess reactants? I have not. I was about to ask, what do you want to cover next week? And if we want to go over moles, we can certainly go over moles. That would be fine. We can go over moles and calculations and the different types of equations you might need to come across. So, by all means, yes, we can go over that next week. So no, don't worry, you've not missed that session. We can certainly go over it. Does anyone else have any questions? Moles would be good because you've got mocks on Thursday. Oh, I'm sure you'll smash your mocks, buddy. So don't worry. We'll certainly go over moles next week. We can easily do that. Finn, that was great, sir. Just covered it in revision for your mocks, which are in 2 weeks. I'm sure you're going to smash your mocks. I'm glad you found the session useful. Fantastic. So yes, we've got we've got 2 weeks, so that's more than enough time for you to prepare for your mocks. In terms of a few tips from me, pass me the questions. If you can do some for practice, that would be great. Make sure you get some notes as well. Okay, that's also quite useful. Does anyone else have any other questions? Oh, here's another question. I'm going to just expand the side bit. What level of education do I have? A PhD or master's? Oh, I wish I had a PhD. No, so I am a pharmacist. So that's what I do. Yeah, that's what I do as a day job. That's what I do full time. So to be a pharmacist, master's in pharmacy. So it's a 4-year degree, so an integrated master's. I am looking to do a PhD. I would love to do one. I'm hoping to do one either this year or next year, part-time as well while I work. So no, I don't have a PhD. Working towards it, but not quite there yet. But I have a master's, so yes. Could we go with titrations next week? I think we could. I certainly think we could squeeze in mold and titrations. I think I could put something together where we kind of merge the two. So we could talk a little bit about titrations and then talk a little bit about the calculations involved with titration, which is mainly moles based. So I think we've got a few good ideas going on here. So yeah, we can certainly do that next week. Moles and titrations, I like that. Like a crossover episode. That was a really cheesy joke. That was awful. I shouldn't drop pharmacy. It's my day job. Clearly, being a comedian is not for me. Yeah, so titrations and moles next week. Do I know any of the content in Chem Paper 1 as you'll be doing it in your mocks? Well, I guess that really depends. I know the content that you'd go over generally for GCSE chemistry. It really depends on what exam board you're doing. So if you're doing AQA or Edexcel, I'm assuming. Well, I don't actually want to assume. You could be doing either. If you do have any other questions about general chemistry, then by all means, you're more than welcome to ask now. Absolutely fine. Doing AQA. Okay. Yeah, I mean, if you've got any other AQA questions for paper 1, then fine. I mean, the Q&A time is for you to ask any question. It doesn't necessarily have to be about the chemistry we've gone over today. It can be about other areas of chemistry, or about study skills or education or anything. So by all means, feel free to ask. Do you have any good chemistry websites? Yeah, you beat me to it, Finn. PMT. Physics and Maths Tutor is a really good website. I'm a tutor on the My Tutor platform, and that's the website that I use to get popular questions. Apart from any resources that I have from my old school like shared area, which I have on an old hard drive. So I use a combination of the two, and I make my own PowerPoints and stuff. It's a very good website. Save My Exams is also really good. Not everything is free there though. There's stuff behind a paywall for some of it. I've never paid for it, so I can't comment on whether the paid content is good, but I'm sure it is. A lot of this is vetted by teachers and stuff, and good website moderators. So you can check that out too. I know like TES, which is mainly geared towards teachers, but there's stuff for students there as well. There are also some resources on there too. That is also done by exam boards, so you can check that out as well. The great thing is nowadays there is a wealth of resources out there. So you're more than welcome to pick, you're more than welcome to sort of like just look around and just pick what you think might be useful. Whether it's like summary notes or questions, you can pick absolutely anything, and I promise you, you will find something that's useful. And if you are ever unsure, there are, apart from myself, there are loads of tutors on the My Tutor platform that are always happy to help. So by all means, feel free to drop us a message, and one of us will support you. Because that's what we're here for at the end of the day, to support you in achieving your aspirational grades, or even beyond your aspirational grades, because I'm sure all of you are more than capable of smashing it. After I suggested it, you used it for maths, and it was great, fantastic. I'm glad you found it really, really useful for maths. I think it's a really, really good website. I don't think I used it actually when I did my A-levels. I wish I had. I don't actually know whether it existed, to be fair. I did my A-levels back in 2015? 2015? No, it couldn't have been 2015. No, it must have been, because I started university in 2015. Yeah, so then that's when I did my A-levels. God, it feels like ages ago. I'm really exposing my age here. Really exposing my age. But yeah, it's a really great website. By all means, just as many resources as you can use and you can find, just utilize them. And use them early, right? Don't wait till the end to then cram and revise. Just do it gradually. Think of it like a marathon. Like you wouldn't sprint in a marathon. You jog really, really slowly. Okay? Conserve energy. A slow burn is the way to put it. Yeah? Does anyone else have any other questions for me at all? Can we do chemistry questions? We can certainly do chemistry questions next. We can certainly do chemistry questions next. What's the word I'm looking for? Towards like next week's session. So if you want, we could practice some like calculations. We can certainly do that. Or you know what might be a good idea, since we said we're doing a bit of titrations and a bit of moles, I could get a titrations calculation up in the lesson space next week, and then we could sort of talk through it and then go over the content a little bit. That might be a good idea. Does that sound like a plan? Next week's session is Thursday at 6 p.m. So every squad is always, the chemistry ones are always Thursday at 6 p.m. So, yes, do make sure to join. There is a link in the description where you can put your email in and then you'll get reminded. Also, if you subscribe to the My Tutor YouTube channel, they will give you a reminder to say that we are live. So, do make sure to sign up to that as well. Finn, you said thank you very much. You appreciate the session, and as it helps recap what you've already learned, it helps consolidate your learning. You are more than welcome, and yes, I will see you next week. Before you leave, make sure to fill in the feedback form. I think there is a link in the description anyway, but I know if you hang on for like 2 seconds or so, Inga will pop the link in the live chat. So just give any feedback you can, positive feedback, any areas for improvement, just anything that you can think of, because the more feedback we get, the better. How many said you can't do it because you have physics mocks on Friday next week? Okay, no, that's fine. That's not a problem. All the sessions are recorded anyway, and they're uploaded to the My Tutor YouTube channel. So you can always send us a you can always send a not send. Sorry, you can always, what's the word I'm looking for here? You can always check out the My Tutor YouTube channel, and then you can click on the video, and then you can watch it back retrospectively after your physics mock. So that's fine. That's not a problem at all. All the best for your physics mock next Friday, though. I think I can improve sessions by uploading slides on the topics, which can make revising easier. Okay, now uploading slides on the topics. I would need to think about how we do that, because I guess I have to upload the slides somewhere, and it's a question of where we could upload them. Because it wouldn't be during the session, because that would be live. I guess what you would be wanting are slides like to read afterwards, and maybe slides you could download. I will. Naturally, the moderators will see that comment, and I think that's a good enough idea. I mean, as many resources as we can give you, that's beneficial. Let me have a think. When the feedback form is sent in live chat, click on the form, type that in, and then we'll review that. It's a good suggestion. It's a very good suggestion. It's just how we implement that. And I guess that's more like a post-session thing rather than a during the session thing. But if it makes the whole experience better, then by all means. Has anyone else had any questions at all? If not, then that's fine. We'll wind down for the evening, and then hopefully I'll see you all next week. But it's been lovely having all of you here. As always, there are no squads without you. So super, super important that you guys attend, and I always appreciate any engagement from all of you. It just makes such a difference, and it really brings the energy, and that's what we're all looking for. Ultimately, what I would say here is make sure you smash the like button on this video if you enjoyed the session. Make sure you leave some feedback. The more feedback you give, the better. It just makes a world of difference, because it lets us know what you guys want, and it lets us know what you guys need from these sessions, especially if we continue the next academic year. Also, make sure to check out the other tutor squads. They also happen during the week. If you subscribe to the My Tutor YouTube channel, you can see when they're going live as well. And my session is always on a Thursday at 6 p.m. And next week we will go over mold and titrations. And I will try and find a titration type calculation to sort of start with. It's a bit of a starter, and then we'll roll into it. Okay? But have a lovely evening, everyone. Thank you so much for joining, and I will see you all next week. Good luck for your physics mock, Mohammed. Best of luck to you. And Phil, I know you've got your mocks in 2 weeks. Best of luck to you as well. And I will see you all next week. But take care until then.